Okay, so I've taken a screenshot of my frames data. Um, I've examined the ribosome binding sequence scores, and also from this data, I can see what start gives us the longest possible open reading frame. Now, genes won't always have the longest possible open reading frame. Sometimes the longest possible open reading frame gives us too great of an overlap of the upstream gene. But often, when there's a gap between two genes, we go with the longest possible open reading frame if there's, again, no other data that points to one start or the other. So you do want to record whether or not you have the longest possible open reading frame with your start. And in this case, we do. Okay, so next what we want to do is look at the BLAST data for this gene. Remember that in addition to coding potential being evidence that we have indeed identified a gene, it also helps to look at whether the protein sequence from this gene matches up with a gene that's already been called in the database. And to determine whether or not we have the right start, remember that starts in homologs are usually conserved. So that's what the BLAST data is going to tell us. Does this gene already exist in the database? And how does the start 783 compare with other starts that were chosen for homologs of this gene? So I'm going to close down my ribosome binding site data and keep frames open because that's pretty handy. And I'm going to go to the BLAST data for this gene. Now, these are all the different homologs that come up through the BLAST analysis in DNA Master. And on one of these tabs, it gives us information that's pretty important. One is that it gives us the E-value, which you'll want to record for at least one or more of the matches in the BLAST data. The E-value, or the expect value, is basically the probability that the match we're seeing here is just a random hit rather than being a very specific match. And because this is such a low number, I think it's 2.8 times 10 to the minus 30, that's a pretty low probability that we have some random match with this GP4 of Murphy. Now, we can also look at the alignment. And so not only does GP4 of TBrady12 match up with GP4 of Murphy, which is also a cluster E phage, the first amino acid of TBrady12 GP4 matches up with the first amino acid of GP4 of Murphy. So that tells us that Murphy has the same start at 783 that's equivalent to 783. You can also click on, I usually just go all the way down and check to see, every time I click on one of these, I can see that in all these other homologs, you can keep scrolling down, with the exception of Rackham, have the same start. So somebody chose a different start for Rackham. But again, as I scroll down, the majority of them match up with the first amino acid. Okay, so I would record the data for maybe MRF4. I'd record that the query first amino acid matches the subject first amino acid, and I would also record the E value, 2.8 times 10 to the minus 30. Okay. Now, the other way that you can look at whether or not a start is conserved in the homologs of other cluster E phage is by going to a program called Starterator. And the way you get to Starterator is you need to go to Ubuntu and type in your password. Your password, I believe, is, I forget what the student password is. I think it's Famerator or Phage or something like that. Anyway, I'm going to go into the faculty version. And on the left-hand side, this pink box is the program called Starterator. And I'm going to click on Starterator. Wait for it to open. And what I want to do is starterate, that's a verb, not the whole genome, but of one one particular gene of a phage genome that exists in Famirator, so one Famirator gene, you could, if you wanted, collect all the all the starter rater data at once for TBRADY12 in one document, which is not a bad idea, but I don't feel like waiting for it by using the whole Famirated phage. But we're going to go to one Famirated gene and just click OK. We're going to put in the name of the phage, TBRADY12, and we're going to put in the gene number, and this is GP4. What you might want to do is make sure and look at the Famirator map of TBRADY12 and make sure in Famirator that GP4 in Famirator is the same as GP4 in DNA Master. And I've already done this, so I'm going to go ahead and push the Starter Rater button. And it only takes a couple of seconds to put forth our report. And it says Starter Rater has completed, link to report, and that will open the report for us. Okay, and so here's the report. Each one of these tracks is one or more homologs from various genomes. So here is a list of each track, tells us which phage genome belongs to which track. Track 1 includes TBRADY12 as well. It's very much the same for all these other phage, including FAJA, which is one of our phage, Murphy4, etc. And then Shere Khan is in track 2, if you're interested in looking at that. And then below that tells us the suggested starts of TBRADY12. Sometimes Starter Rater gives you a suggested start, and in this case it says 783, which is start number 2, is what it suggests as a start. But sometimes it gives you all the starts for TBRADY12 or whatever phase you're looking at because it doesn't really know which start is correct. In this case, it has chosen 783. So let's look at why it possibly chose start 2 or 783 as the start for TBRADY12. If you look at all the possible starts, some homologs have a start further upstream in maroon as a possible start, but not all of them have this. If you look at start 2, and this would be the track for TBRADY12, it's a thick blue line, and that means it's the start that was chosen for this homolog. And then the thick blue line all the way down here for each of these also shows that that's the start that was chosen for other versions of this gene and other genomes. And pretty much the majority of them all have chosen the equivalent of what is the 783 start, with an exception of whatever this one is in track 11 and whatever this one is down here in track 19. Okay, well, start number 1 is very likely, even though it makes the longest possible ORF in some of these homologs, it's not present in every single one, so it's not likely the start. But check out 783, or whatever the equivalent is in the homologs. It is present in every single homolog, and only in a couple of cases did somebody not choose this as the start. So this is good evidence that, 1, the start is conserved in the homologs, and all the homologs, and for the most part it was chosen as the start for those other homologs. So this is further evidence that the 783 start is conserved and is so far the most frequently chosen start for the homologs. So I'm going to click out of this and go back to my DNA master. So this is all this data you're going to want to record in your DNA master notes section. And I have a second version of this file here where I've actually gone ahead and done that. Click on 4 again. Here's the original Glimmer call. I've put in what I think the start is, and of course the stop doesn't change. For coding potential, I've written that it's the only start to include all CP. For SCS, I've said that the start that I've chosen agrees with both Glimmer and GeneMark. I've recorded the gap, which in this case is an overlap. There's a 4 base pair overlap. If it was a gap, I'd say there was a X base pair gap. For my BLAST data, I've written that there's a match with Murphy, GP4. I've recorded the expect value, and I've also recorded the amino acid 1 of the query, TB12, matches amino acid 1 of Murphy. Okay? Is it the longest possible open reading frame? Yes, and it's also the suggested start by starter rater. Now, we haven't discussed how to determine function and source of function, so we can leave those two note sections blank. But here's my logic for choosing 783 as the start. It's the only start to include all the coding potential in both GeneMark SMEG and GeneMark S. It produces a 4 base pair overlap, which we know is ideal. It also produces the longest open reading frame, also ideal. And the product aligns with the first amino acid of MERF4, but also DESC5 and BASC5. So I've provided all the information that helped me choose 783 as a start, and also the logic behind choosing 783 as a start. Once you've entered all this information, what you want to do is click Post and Validate, okay? And then you need to, once you've taken a break from your annotation, you want to save your file, and I'm going to save mine in a certain drive. I'm going to save mine in Dropbox. You want to make sure you're going to save all your files in a folder where you're always going to know where to find them. Oops, I'm going to go back. I'll put mine in the tbrady12. And I'm going to give it a name, and I've called this one tbrady12 Sally. And I'm going to, what I typically do, because I keep making additional versions each day that I work on my genome, I might give it a number. If this were tbrady12 1, I might give this one a number 2, that I know it's a version 2. And that way, whatever changes I made today will be saved in this version. But if for some reason something happens to this file, I always have tbrady12 Sally-1 to go back to. I'm going to push save. Okay, so now I have, and if I want to close these down, so I can close these down, it says save tbrady12 Sally example before closing, and I'm actually going to say no because I've already saved this as a different file.